In this video, we're going to look at how a binary search works. Binary search is significantly faster and more efficient than using a linear search. However, it is harder to write in code and it is harder to write as an algorithm. This is one of the reasons we're not going to get you to do it. What we're going to look at is a slightly simplified version of a binary search that uses a lot of the same principles, but isn't quite as complicated as you might see when you get up to GCSE level, but at least gives you a good idea of how a binary search works. The first thing you notice for binary search, one of its negatives, is that the data must already be sorted. So this array here, or list, from position 0, position 5, is already sorted in the correct order. A binary search does not work with data that is not sorted. A linear search would work better there. Now, so we've got the cards in the right order. What happens is, with a binary search, is it first looks at the length of the array. So first thing it does in the program or pseudocode is it measures the length of the array. Now, I don't mean in centimeters or in inches or anything other kind of data from maths. What I mean is it looks at how many positions there are in the list. So here we've got 0, 1, 2, 3, 4, 5. So it knows the length of this list is the number 5. What it then does is it sets the lower position, or what's called a lower bound, to the first position in the array, so 0. It also sets something called the upper bound, which is the last position in the array, in this case 5. And then what it does is it finds the middle of that, or half of that. So with 5, that would give us 5 divided by 2 gives us 2.5. Now, there isn't a position 2.5, so what the computer does is it rounds that number up to the next whole number. So instead it becomes the position 3. Okay, so 0, 1, 2, 3. So this is my lower bound position, this is my upper bound position, and this here is my mid bound position. So what it does is it does that and goes, okay, is the mid bound position the card you're looking for? Well, what we're going to do is we're going to look for the 3 of diamonds. Well, no, that's not the position that I want. And then what it does is, okay, if it's not what you want, is it higher or lower than the card you're looking for? So in this case, I'm looking for the 3 of diamonds. This is higher or bigger than the card I'm looking for. So what it does in a sort of way is it kind of moves these cards to one side, and it starts that again, does it like a loop, and says kind of while not found, it will keep going to find the cards that it wants. So it's exactly the same thing. It looks at the length now. The length is 4. It divides 4 by 2 to give it 2. So this is the lower bound. This is the upper bound. And position 2 is the mid bound. So 0, 1, 2. Okay. Now in this case, probably not the best example on 2 3s, but it still works. It says, is the card looking for the middle bound? Well, no, it's not. Is the card it look for to the left or to the right of what it wants? In this case, it's to the right. So what it then does is it shifts this card across to here, and it just keeps these 3 cards. It then does the loop again, or what's called another iteration again, and goes, okay, this is the lower bound, this is the upper bound, which is 3. 3 divided by 2 gives us 1.5. Now in this case, to simplify it a little bit for us, we're actually going to round down, because if we round up, we're just going to get this card instead to make it a little bit easier for us. So what it does is it says to be in the midpoint and says, is this the card I'm looking for? Well, it is, so it sets some kind of value to say I've found. You can, if you want to experiment, do an giveaway which is a 2, because then what would happen is that you'd lose this card. You then be left with these 2 cards here, and the midpoint 2 is a half, which would give you 1, and the mid bound and the upper bound can be exactly the same. So now the mid bound and the upper bound are the same. Mid bound is the right card that I'm looking for. Depends how complicated and how much depth you want to go in with a binary search. So again, you're going to have a go at doing that, but this time we're not going to get into write a pseudocode because it is slightly more complicated at KS3 level to be able to write an algorithm to that level of detail.